a limited budget but must get sophisticated air defense weapons currently facing the Serbian military. After conducting an in-depth study, their choice fell to the Pantsyr-S1E mobile defense system. It is interesting to look at their choices because Serbia, formerly Yugoslavia, made history, where their air defense system S-125 Neva, Pechora surface-to-air missile managed to shoot down the Lockheed F-117 Nighthawk stealth fighter 30 kilometers to the northwest the city of Belgrade in 1999. The world at that time was surprised. How could a simple Serbian defense system be able to shoot down modern aircraft that claimed stealth? The event was filmed on the big screen that brought together US F-117 Nighthawk pilots with the Serbs who shot the plane. In the confession of the shooter, he had fiddled with tweaking his weaponry radar and succeeded in finding traces of NATO aircraft on his radar. Now in 2020, Serbia is renewing their air defense system with Pantsyr-S1E's self-propelled air defense system battery, released Janes.com, the 5th of May 2020. Russia sent the weapon to Serbia in 4 shipments between February 22 and March 3, 2020. While visiting batteries in the major Milanovic barracks on the outskirts of Jakovo, Belgrade, Serbian President Aleksandar Vučić said that Pantsyr-S1E completed the 3rd Missile Battalion of 250's RVOPVO Air Defense Brigade 250 RBRPVD. The Serbian military plans to hold a large training camp next October, including to try on Pantsyr-S1E. I don't know what modifications Serbia will make with their Pantsyr-S1E. The Panther missile system is a family of self-propelled, medium-range surface-to-air missile and anti-aircraft artillery systems. Starting with the Pantsyr-S as the first version, it is produced by KBP Instrument Design Bureau of Tula, Russia. The system is a further development of 2K-22 Tunguska and represents the latest air defense technology by using phase array radars for both target acquisition and tracking. The Pantsyr-S1 was designed to provide point air defense of military, industrial, administrative installations against aircraft, helicopters, precision munitions, cruise missiles and UAVs, and to provide additional protection to air defense units against enemy air attacks employing precision munitions, especially at low to extremely low altitudes. The first finished version was completed in 1995 with the 1L-36 radar. Later another was designed. It is a short to medium-range ground-based air defense system, wheeled, tracked or stationary with 2 to 3 operators. Its air defense consists of automatic anti-aircraft guns and surface-to-air missiles with radar or optical target tracking and radio command guidance. Its purpose is the protection of civil and military point-and-area targets. For motorized or mechanized troops up to regimental size or as defensive asset of higher-ranking air defense systems like S-300, S-400. The system has capability for anti-munitions missions. It can hit targets on the waterline, above water. It can operate in a fully automatic mode. It has the ability to work in a completely passive mode. The probability of hitting a target for one rocket is not less than 0.7 with a reaction time of 4 to 6 seconds. It can fire missiles and gun armament while in motion. For its main radar station, early detection in height may be between 0 to 60 degrees or 26 to 82 degrees depending on the mode. The system has claimed significant advantages over other systems, such as Croix-Hauling, France, Roland 3, France plus USA. Rapier 2000, UK, CRAM, Germany plus USA. This is not confirmed by comparative testing, but clearly follows from declared limit of possibilities of systems 2010. In 2013, there was a variant with 2 radar stations for early detection. The system has a modular structure which enables a fast and easy replacement of any part. After receiving target coordinates from any source, it may defeat the target using all the radar except the early detection radar, within a range from -5 to +85 degrees vertical. The interval between missile launches is 1 to 1.5 seconds, a world record for analog systems. Pantsyr-S1 carries up to 12 57E6, export designation 57E6E, two-stage solid fuel radio, optical, command-guided surface-to-air missiles and sealed ready-to-launch container tubes. Missiles are arranged into two 6-tube groups on the turret. The missile has a bicaliber body, consisting of two stages in a tandem configuration. The first stage is a booster, providing rapid acceleration within the first 2 seconds of flight, after which it is separated from the sustainer stage. The sustainer is highly agile and contains the high-explosive multiple continuous rod fragmentation warhead, as well as the contact and proximity fuses, guidance, flare and radio transponder. The missile is not fitted with a seeker to keep target engagement costs low. Target and missile tracking is instead provided via the system's multi-band sensor system, and guidance data is submitted via radio link for up to 4 missiles in flight. The system is capable of tracking and guiding 4 missiles fired at 4 distinct targets. Operationally, however, 2 missile salvos are typically fired at each target. The 57E6 missile is believed to have a kill probability of 70 to 90% and have a 15-year storage lifetime in its sealed launch container. Pantsyr-S1 combat vehicles can fire missiles on the move. Additional missiles, one specifically designed to engage unmanned aerial vehicles, and another one hypersonic, developing speeds of more than Mach 5, have been developed for the Panther system. 2 dual-2A38 M30mm 1.2-in autocannon guns are fitted with 700 rounds of a variety of ammunition, high explosive, fragmentation tracer, and armor-piercing with tracer. Ammunition type can be selected by the crew depending on the nature of the target. Maximum rate of fire is 2,500 rounds per minute per gun. Range is up to 4 kilometers (2.5 miles). The combined gun missile system has an extremely low altitude engagement capability. Targets as low as 0 meters AGL can be engaged by this system. Wheeled combat vehicles have to be jacked up to keep the machine in the horizontal position and be able to fire the gun with full accuracy. The KAMAZ 6560 has 4 oil hydraulic jacks for this purpose. The Pantsyr-S1 fire control system includes a target acquisition radar and dual waveband tracking radar, designation 1RS-1E for export models, which operates in the UHF and EHF waveband. Detection range is 32 to 36 kilometers (20 to 22 miles), and tracking range is 24 to 28 kilometers (15 to 17 miles) for a target with 2 square meters (22 square feet). RCS-42 can also reliably achieve more, to 45 kilometers (28 miles) 10. This radar tracks both targets and the surface-to-air missile while in flight. Minimum target size 2 to 3 square centimeters (0.31 to 0.47 square in), 0.0004 square meters (0.0043 square feet) 43, as well as radar. The fire control system also has an electro-optic channel with long-wave thermal imager and infrared direction finder, including digital signal processing and automatic target tracking. A simplified, lower-cost version of Pantsyr-S1 is also being developed for export, with only the electro-optic fire control system fitted. The 2 independent guidance channels, radar and electro-optic, allow 2 targets to be engaged simultaneously. And 4 for more recent options. 2012. Maximum engagement rate is up to 10 to 12 targets per minute. Types of purposes: aircraft, UAVs, helicopters, anti-radar missiles. Detection range of AGM-88 HARM missile 13 to 15 kilometers (8.1 to 9.3 miles). Air-launched cruise missiles.